Okay, I'm going to show you some cheap thrills. So if you say partition report, you see we have a B drive, which is a RAM disk. Then we have FAT32, FAT32 ATA. Then we have a TAPI. Okay, so the file system is FAT32. That's a Microsoft version that, or a standard that that's pretty common. If you get a memory stick, it's probably FAT32, and they probably at one point they had to pay Microsoft just to format with that format. Okay. Anyway, so we want Microsoft to use Red C, and that's the version I invented. It's nothing special. I did not want to get sued, so I made it as simple as possible. But actually, there's another reason. I want it as simple as possible so that because our purpose is to make people have fun with internals. Neil deGrasse Tyson said, if a kid breaks an egg, that's a science experiment. So here's what we're going to do. Control D. I'm going to take Control Insert, or I guess I always use Control Insert instead of Control X, Control C, Control V. We want Control C, don't we? Control C. Now we go up to my B drive. Open it, nothing happens. Do Control V. Okay, now we have some files on the B RAM disk. Okay, now we go Shift Escape to quit. Then we say Drive B, Directory. Okay, let's go into that directory. Now we have some files. Let's put some stuff in here. Okay, this looks good. Let's copy that. We're gonna move it to oh, I copied it. That's bad. Okay, I'm deleting the old one. If it has a Z, it's compressed when it's stored on the disk. Notice the size changed. Compressed versus uncompressed. Don't worry. It's too small to. Anyway, now here's what makes our operating system special. Directory. You can look up the parameters. It's a mask and then it's full. So if we say star, comma true for full. Now we have something called cluster. This is a RAM disk, so that means it's temporary. So we can screw it up and it won't cause any problem. Maybe we crash, but it crashed, you just reboot. It's like a Commodore 64 DOS. So anyway, the worst that'll happen with a RAM disk is we screw it up, and then when we access it, it crashes the system. But it's okay, that's not a problem. Why is that a problem? You've been brainwashed. Everybody's saying, oh, crashing is really terrible. Did you hear about the crash? Oh, let's mock them for crashing. It's nothing if it's, well, it depends. If it's designed for crashing, it's not a problem. DOS could crash, Commodore 64 could crash. It's like a motorcycle and saying, oh, did you know you can fall over on a motorcycle? That's pretty serious, actually. But I screwed up my argument. The motorcycle example does not work. It's a kayak versus a Titanic. Anyway, I'm getting distracted. So, let's take the cluster number, say dump cluster 0x, and if we do, let's look at the parameters. Write and then number. You can go down a cluster chain, I do believe. So if we say write, it will wait until we hit escape and then it will rewrite the cluster. Holy shit, we can rewrite disk clusters. Uh-oh. Oh, I screwed. Oh, well, good thing we didn't crash the video. Okay, so now, folks, when we hit escape, it'll rewrite the cluster. Let's look at this. This is ASCII. This is the file. Look at that. We're looking at the raw disk block, and there's the file. I don't bother to erase the garbage that's not used. How do we want to abuse this? Hello, Wood. Okay, now I hit escape, and it rewrote it. Right cluster. Now, what's going to happen? Oh, shit. Okay, that's just junk on the command line. So what's going to happen? We're going to edit this. Hello, Wood. So do you understand what we just did? The disk is made of blocks. If we say directory star true, now we're going to get psycho dot is the current directory. Oh, are you thinking what I'm thinking? Dump cluster. Now, if this is not cheap thrills for kids, I don't know what is. This is a directory. Holy shit. It's designed to be as simple as possible. 64-bit block numbers, fixed length directory entries, 64-byte entries. Let's see. Budweiser. Okay. So we hit escape. Now we do a directory. Let's look at this before we move on. What was the block number we did for test? Let's see if we can find the block number in the directory entry. It was, what was it? 8C something? Well, if we need some help, we can always go cdir. Now this part right here is exactly how it is stored on disk. Attribute name, cluster size, date, time. Attribute name, cluster size, date, time. Attributes the first 2 bytes. Name. What was it? Attribute name, cluster size, date, time. This 8.2. Uh-oh. Oh, I'm looking. Uh-oh, I'm all confused. Let's do a directory, see where it is. Okay. 34 bytes, 8C44 test. Look, you see Budweiser? We changed the name by accessing disk blocks. Holy shit. Okay, so we really want to find a 448C. I don't see a 448C anywhere. Let's do that again. Maybe it's out of date. I don't know what the fuck. So let's dump. We want to look at we just want to see the cluster number. Oh! No, I don't know. Okay, so dump cluster 0x. So that's the date right there. I'm really disappointed. I'm looking at the wrong thing, it must be. Psalmody test. Oh, it sorts them, by the way. Oh, this is .z. This has been deleted. Oh, tricky, tricky, tricky. That's something you won't forget. Don't worry, these are stored contiguous. This file system, everything is stored contiguous. Files do not have a fat table, just a bitmap. Okay, so here it is. Here's our file, 8C44. There's the disk block right there. Isn't this cool? Now you know how a disk works. That's all there is to it, except everybody else does it complicated. But anyway, how about that?